Welcome to the session on engineering graphics. In today's session, we are going to solve one problem on rectangular prisms lateral surfaces development. So the problem statement given here is a rectangular prism of base 25 mm into 40 mm and axis length 60 mm is resting on HP with its base such that the lateral surface containing longer edge of the base is inclined to VP at 30 degrees. The prism is cut by a cutting plane which is inclined at 40 degrees to HP and perpendicular to VP and bisecting the axis. Draw the development of the remaining portion of the prism. So this is the problem statement you are given, and this problem statement will look similar to that of the projection of solid problem statement, where you used to get the solid is resting on corner or on edge, but here the solids are going to rest on HP with its base, but the lateral surfaces or the base edges will be having inclination in the first edge itself. So here they are saying that the lateral surface containing longer edge of base is inclined at 30 degrees to VP. So first we have to start with this, and then we can solve the remaining part of the problem statement. So to do that, first you have to draw the XY line. You have to locate HP VP like this, and then you have to take this 30 degrees line. So we are taking this 30 degrees line because the solid is going to rest on HP with its base, and the lateral surface containing longer edge of the base is inclined to VP at 30 degrees. Okay, so this, to accommodate this part of the statement, we are taking this as 30 degrees. So once you do this 30 degrees, then you can go to the next step where you have to construct this rectangle top view of the rectangular prism. So it will be a rectangle, and we'll be naming as usual how is to give it to for a projection of solids. So A1, B, B1, C, C1, D, D1 would be the corners of the face as well as the top face. Then 25 mm is the dimension, 40 mm is the dimension, and axis will be getting by connecting two diagonals of the rectangle, and will be giving the points as O, O. So once you complete this, you will be projecting all the points till XY, and then further we will be taking the axis as 60 mm and will be completing front view of this rectangular prism as shown here. So this would be the front view of the rectangular prism, and this would be the top view of the rectangular prism, and the prism lateral edge is having 30 degrees inclination. Now we have reached to this part, so remaining we can complete as shown here. So the prism is cut by a cutting plane which is inclined at 40 degrees to HP and perpendicular to VP and bisecting the axis. So we are bisecting the axis first. So axis length is 60, so we are bisecting it. So the length after bisection, it will be 30 here and 30 here, so we have marked this 30. So once you have marked this 30, from this point you have to take the inclination of the cutting plane. Cutting plane inclination is 42 HP, so that inclination we have to show. So cutting plane inclination, so that we have to show here. So this is the 40 degrees inclination which is for the cutting plane, 40 degrees to HP and perpendicular to VP. So perpendicular to VP means it will appear as a line in front view. So this is the perpendicular to VP and inclined at 40 degrees to HP. So we have started from this point, which is the midpoint of the axis. Then from here we have drawn this line, and further we can extend this line like this. So we have extended this line. So now this is the line having angle 40, so which we have shown it here. So once we do this, then we have to show this line as a cutting plane, and we have to give the remaining namings in the front view as well. So A1, B, B1, O, O1, D, D1, C, C1 dash, then A dash, B dash, all these points you have to name it. And then the line which is drawn at 40 degrees with respect to horizontal has to be shown as cutting plane line. So cutting plane line representation we had seen in the earlier class. So you have to represent it by chain line, and the end should be thick with these arrowheads with name of the cutting plane as SS. So once we do this, then we can go to the next step. So where we have to make the remaining portion which is above here. So in this figure, whatever these arrowheads are there, these arrowheads indicate that the portion above this plane which is here, this is imagined that cut and remove. This portion is cut and remove. So it is an imagination. So that's why we are showing it as thin lines, and the portion which is here, that is retained portion or the remaining portion of the prism, that we are making it as thick lines. Okay, so this would be thin, this would be thick, and we'll be having this cutting plane representation like this. Then what we'll be doing, we are going to project all the lines. This xy line will be extending from here, which is parallel to xy, and then we'll be having this line a dash line, which will be extended further here, and this line will be taken as the distance same as 60. So what kind of method of projection or the method of development which we are using here is called as a parallel line development. So parallel lines, we are drawing line parallel to xy and parallel to the top. It's two lines we have drawn, and this first line we have marked it. We have connected bottom line and the top line, and we have got this as 60, okay, which is the height of the prism. So once we do this, then we can mark the remaining lines also. So if it is rectangular prism, so if you start from this point here, okay, so we'll be always starting the naming from the extreme left point. So from here to here, A to B or A1 to B1 distance is 25, then B1 to C1 is 40, C1 to D1 is 25, and D1 to A1 is again 40. So that we are going to show it here. So A1 to B1 is 25, B1 to C1 is 40, C1 to D1 is 25, and D1 to A is 40. So that we have taken, and we have got all the four sections or the four lateral surfaces of rectangular prism. So once we get this, then we have to mark the points on this. Okay, so first we have to mark the cutting points here. So to mark the cutting points, here we go. So here we start with AA1. So AA1. So AA1 is the edge here, and it is cut by at this point. So we are naming this point as 1 dash because we are naming it in the front view. And when we project it back here to AA1, so this will become 1. Then AB is here, which is not cut. A1 B1 is there, which is not cut. Then next is BB1. So BB1 is here, BB1 is cut here. So that point we are naming it as 2 dash, and that we projected back at BB1. We'll be getting it here. Then B2C. So B2C is here, which is not cut, and B1 to C1 is here, which is not cut. So next point is CC1. So CC1 is here. So CC1 is here, and it is cut at this point. So this point will be naming it as 3 dash, and when we project it back to the top view, we will be getting as 3. Then C2D. C2D is here, it is not cut, and C1 to D1 it is here, it is not cut. So we are not having any cutting points there. Then DD1. So DD1 is here. So DD1 is cut at this point. So we'll be naming this point as 4 dash. And we'll be projecting it back to the top view, and we'll name it as 4. Then further D to A. D to A is here, D to A is, it is not cut, and D1 to A1. D1 to A1 also it is not cut, so we don't have to mark any cutting points. So only the lateral edges are cut, that is AA1, BB1, CC1 and DD1. So AA1 is represented with cutting point 1 dash, BB1 with 2 dash, CC1 with 3 dash, and DD1 with 4 dash. Now these are the cutting points which we have marked in the top view as well as the front view. Now with respect to the front view, we have to project them. Why we are selecting the front view is that because front view is representing the height of the prism. So with respect to that height, we are having these lines, and now we are going to project these points on the respective cutting edges. So first we'll project point 1. So point 1 we are projecting it on AA1 because it is on AA1. So one point we have projected it AA1, and we have named it here. And when you are naming the points for the development, you will be naming them with capital letters. So this is A1 with cutting point 1 you have marked. So similarly 2 you will be having on BB1, 3 will be having on CC1, D will be having on 4 will be having on DD1, and again at the last edge which is AA1. So again you will be projecting this one here on AA1 like this. So now you have got 1 here, 2 here, 3 here, 4 here, and then back to 1 again. So 1, 2, 3, 4, 1. So you have got all the cutting points. So once you have got the cutting points, then you can connect this 1 to 2, 2 to 3, 3 to 4, 4 to 1 by thick line. So you can connect them by thick line, and then further 1 to A1, 4 to D1, 3 to C1, 2 to B1 and 1 to A1. Again you will be marking them as dark lines because these are the edges of the solids which will be retained after cutting, and then you will be connecting A1 to A1, which is the bottom edge. So when you connect them by thick line, whatever portion you are going to get here is nothing but the development. It means that if you have got this portion, okay, so you have got the rectangle of 25 plus 40 plus 25 plus 40, so which is almost equal to 130. 130 into height is 60. So if you have got a piece of paper which is 130 mm into 60 mm, and if you fold it at this edge, this edge, this edge, this edge, this edge, you will be getting the development of the rectangular prism. And when this prism is cut by a cutting plane having inclination with respect to HP as 40 degrees, and if it is bisecting the axis, then if you fold it at 1 to A1, 2 to B1, 3 to C1, 4 to D1 and 1 to A1. So if you fold it at these points and if you connect this 1 A1 to this 1 A1, you will be getting a development of remaining portion of the prism. So like this you will be able to complete the development for the rectangular prism. Thank you.